GFCI outlets are a critical safety component in electrical systems, protecting individuals from electrical shock. Establishing a routine preventive maintenance program for GFCI outlets is essential, particularly in large facilities with numerous installations. Determining the appropriate testing frequency is a key aspect of this program. Several industry organizations offer recommendations for GFCI outlet testing. The National Fire Protection Association (NFPA) recommends testing GFCI outlets at least monthly, as outlined in NFPA 70, the National Electrical Code. The Electrical Safety Foundation International (ESRI) suggests a quarterly testing frequency. In addition to industry recommendations, it's important to consider manufacturer guidelines. Some GFCI outlet manufacturers recommend testing their products every 30 days, or according to the specific frequency outlined in the product instructions. It is imperative to consult the manufacturer's documentation for specific guidance on testing frequency and procedures. Several factors can influence the optimal GFCI testing frequency. Firstly, environment plays a crucial role. GFCI outlets located in wet or hazardous areas may require more frequent testing due to the increased risk of exposure to moisture and corrosive elements. Secondly, usage patterns should be considered. Outlets that are used heavily or supply power to critical equipment should be tested more often to ensure their continued reliability. Thirdly, local building codes may impose additional requirements for GFCI testing frequency. It is essential to consult local regulations to ensure compliance. Based on industry and manufacturer recommendations, a quarterly testing schedule serves as a reasonable starting point for a GFCI preventive maintenance program. However, the actual frequency may need to be adjusted based on the specific environmental conditions, usage patterns, and code requirements of the facility. A suggested preventive maintenance routine for GFCI outlets includes several key elements. Firstly, quarterly testing is crucial. All GFCI outlets should be tested using the test and reset buttons to verify their proper functionality. Secondly, annual inspections are necessary. Each GFCI outlet should be visually inspected for physical damage, loose connections, or any other visible defects. Thirdly, as-needed testing is essential. GFCI outlets should be tested immediately after any repairs or modifications to the electrical system to ensure they are operating correctly. It is essential to maintain thorough documentation of all GFCI outlet tests and any corrective actions taken. This documentation serves as a record of maintenance activities and can be valuable for identifying trends or potential problems. Consider using a standardized form or electronic system to record the date of the test, the results, any corrective actions taken, and the initials of the person performing the test. Retain these records for a predetermined period, in accordance with company policy and any applicable regulations. To perform a test of the GFCI receptacle, you will need to locate the test and reset buttons on the face of the receptacle. The test button is typically labeled test, and the reset button is labeled reset. Firstly, plug a night light or receptacle tester into the GFCI receptacle. The light should turn on or the tester should show proper wiring if the GFCI is functioning and wired correctly. Secondly, press the test button. This should trip the GFCI, cutting off power to the receptacle. The night light should turn off or the receptacle tester should indicate an open circuit. Thirdly, verify that the night light has turned off or the receptacle tester shows no power. If the power remains on when the test button is pressed, the GFCI receptacle is defective and should be replaced by a qualified electrician. Finally, press the reset button. This should restore power to the receptacle. The night light should turn back on or the receptacle tester should indicate proper wiring. If the GFCI does not reset, it may be defective or there may be a ground fault condition in the circuit that needs to be addressed by a qualified electrician. When inspecting the GFCI receptacle, look for physical damage. Check the receptacle face for cracks, chips, or other signs of damage. If damage is present, the receptacle should be replaced. Secondly, check the receptacle for loose connections. Gently tug on the wires connected to the receptacle to ensure they are securely attached. If any wires are loose, they should be tightened by a qualified electrician. Thirdly, look for any other visible defects such as discoloration, corrosion, or signs of overheating. If any of these conditions are present, the receptacle should be inspected and potentially replaced by a qualified electrician. The NEC requires GFCI protection in various locations to enhance electrical safety. GFCI protection is required for 125 volt, 15 and 20 amp receptacles in bathrooms. This requirement aims to protect users from electrical shock hazards in areas where water is likely to be present. GFCI protection is also required for 125 volt, 15 and 20 amp receptacles in kitchens. This requirement applies to receptacles serving countertop surfaces to protect against electrical shock hazards when using appliances near water sources. GFCI protection is mandated for 125 volt, 15 and 20 amp receptacles in garages. Garages often have damp conditions and can pose a higher risk of electrical shock. GFCI protection is required for all 125 volt, 15 and 20 amp receptacles outdoors. This includes receptacles on decks, patios, and other outdoor areas. Outdoor receptacles are exposed to moisture and other environmental factors that increase the risk of electrical shock. GFCI protection is necessary for 125 volt, 15 and 20 amp receptacles in crawl spaces at or below grade level. Crawl spaces are often damp and can pose a shock hazard. GFCI protection is required for 125 volt, 15 and 20 amp receptacles in unfinished basements. Unfinished basements typically have concrete floors and can be damp, increasing the risk of electrical shock. GFCI protection is required for 125 volt, 15 and 20 amp receptacles within 6 feet of the outside edge of a sink. This requirement applies to receptacles in laundry areas, utility rooms, and other locations where sinks are present. GFCI protection is required for all receptacles supplying boat hoists. Boat hoists are used in wet environments, and the risk of electrical shock is high. GFCI protection is also required for receptacles powering swimming pools, spas, and hot tubs. These areas pose a significant risk of electrical shock due to the presence of water. It is important to note that these are just some of the locations where GFCI protection is required by the NEC. Consult the latest edition of the NEC for a complete list of requirements. If any of these outlets are not working, there are several steps to troubleshoot the problem. Firstly, check the reset button on the GFCI receptacle. If the GFCI has tripped, the reset button will be in the trip position. Press the reset button to restore power. Secondly, check the circuit breaker. If the circuit breaker has tripped, reset it. If the circuit breaker trips again immediately, there may be a short circuit or ground fault. Thirdly, test the GFCI receptacle with the GFCI tester. This tester will simulate a ground fault and verify that the GFCI is functioning correctly. Fourthly, check the wiring connections. Make sure that all of the wiring connections to the GFCI receptacle are secure. Loose connections can cause the GFCI to malfunction. Fifthly, check the wiring for damage. Inspect the wiring for any signs of damage such as cuts, abrasions, or burns. Damaged wiring can cause a ground fault. If you have checked all of these things and the GFCI receptacle is still not working, it should be replaced by a qualified electrician. The lifespan of a GFCI receptacle can vary depending on several factors, including the quality of the receptacle, the frequency of use, and the environmental conditions. However, most GFCI receptacles are designed to last for approximately 10 to 25 years. Several signs indicate that a GFCI receptacle may need to be replaced. Firstly, if the GFCI receptacle trips frequently, even when there is no apparent ground fault, it may be nearing the end of its lifespan. Secondly, if the GFCI receptacle fails to trip when the test button is pressed, it is defective and should be replaced immediately. Thirdly, if the GFCI receptacle shows signs of physical damage, such as cracks, chips, or discoloration, it should be replaced. Fourthly, if the GFCI receptacle feels warm to the touch, it may be overheating and should be replaced. To replace the GFCI receptacle safely, firstly, turn off the power to the circuit at the circuit breaker. Secondly, test the receptacle with a non-contact voltage tester to ensure that the power is off. Thirdly, remove the faceplate of the receptacle. Fourthly, unscrew the receptacle from the electrical box. Fifthly, carefully disconnect the wires from the old receptacle. Sixthly, connect the wires to the new receptacle, matching the wire colors to the terminals. Seventhly, screw the new receptacle into the electrical box. Eighthly, attach the faceplate. Finally, turn the power back on at the circuit breaker and test the GFCI receptacle to ensure that it is working properly. When selecting a GFCI receptacle, there are several factors to consider. Firstly, choose a receptacle that is listed by a recognized testing laboratory, such as Underwriters Laboratories, AL, or Intertek, ITL. This listing ensures that the receptacle has been tested and meets safety standards. Secondly, select a receptacle with a current rating that is appropriate for the circuit. GFCI receptacles are typically rated for 15 amps or 20 amps. Thirdly, consider the environmental conditions in which the receptacle will be used. If the receptacle will be exposed to moisture, choose a weather-resistant GFCI receptacle. Fourthly, look for a receptacle with a tamper-resistant design. Tamper-resistant receptacles have shutters that prevent children from inserting objects into the slots. There are also several common mistakes to avoid when installing and maintaining GFCI receptacles. Firstly, do not install a GFCI receptacle on a circuit that is not properly grounded. A GFCI receptacle will not function properly if it is not grounded. Secondly, do not overload the circuit. Overloading the circuit can cause the GFCI receptacle to trip frequently. Thirdly, do not paint over the GFCI receptacle. Paint can damage the receptacle and prevent it from functioning properly. Fourthly, do not use a GFCI receptacle to protect an entire circuit. GFCI receptacles are designed to protect only the receptacles that are connected to them. Finally, do not ignore a GFCI receptacle that trips frequently. Frequent tripping indicates that there is a problem with the circuit that needs to be addressed. Remember, a well-maintained GFCI system is crucial for ensuring electrical safety. Regular testing, inspection, and timely replacement of GFCI receptacles can help prevent electrical shocks and protect individuals from harm. Prioritizing GFCI maintenance is a vital aspect of any comprehensive electrical safety program. The National Electrical Code, NEC, Section 210.8 specifies where GFCI protection is required for personnel. This section mandates GFCI protection for 125 volt through 250 volt receptacles supplied by single-phase circuits rated 150 volts or less to ground in specific locations. These locations include bathrooms, kitchens, garages, outdoors, crawl spaces, unfinished basements, and areas within 6 feet of sinks. The specific requirements may vary depending on the edition of the NEC adopted by the local jurisdiction. Article 547 addresses agricultural buildings. GFCI protection is required for receptacles in areas of agricultural buildings that have conductive flooring or are subject to wet locations. This is because livestock and agricultural environments often present increased risks of electrical shock. Section 555.3 requires GFCI protection for receptacles on floating buildings and marinas. These locations are inherently wet and pose a high risk of electrical shock due to the proximity of water. Section 590.6 mandates GFCI protection for temporary wiring installations. Temporary wiring is often used in construction sites and other temporary locations where the risk of electrical shock is higher. Section 680.5 specifies GFCI protection requirements for swimming pools, spas, and hot tubs. These areas pose a significant risk of electrical shock due to the presence of water and conductive surfaces. Section 682.15 states that GFCI protection is required for receptacles and electrical equipment located within specific distances of natural bodies of water. This requirement aims to protect individuals from electrical shock hazards near lakes, rivers, and other bodies of water. It's crucial to consult the specific edition of the NEC adopted by the local jurisdiction and to understand the nuances of each requirement to ensure compliance and maintain electrical safety. The NEC guidelines help minimize the risk of electrical shock in various settings. GFCI devices are not a substitute for proper wiring and grounding practices. They serve as an additional layer of protection to reduce the likelihood of serious injury or death in the event of a ground fault. Always follow the manufacturer's instructions when installing and testing GFCI devices. When performing electrical work, always follow safe electrical practices, including de-energizing circuits before working on them and using appropriate personal protective equipment such as gloves and eye protection. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electrical safety is a serious matter, and it is important to take the necessary precautions to protect yourself and others from electrical shock hazards.